Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is simple pendulum, time period and factors affecting it. The simple pendulum is one of the most fundamental concepts in physics, demonstrating the periodic motion of an object under the influence of gravity. A simple pendulum consists of a small mass, known as the bob, suspended from a fixed point by a light, inextensible string. When displaced and released, the pendulum swings back and forth in a regular motion, making it an excellent example of harmonic motion. The time taken for the pendulum to complete one full oscillation, moving from one side to the other and back, is called its time period. The time period of a pendulum depends on a few key factors. The length of the string plays the most significant role. A longer pendulum has a greater time period, meaning it swings more slowly. Conversely, a shorter pendulum swings faster, reducing the time period. This relationship between length and time period is crucial in designing clocks and measuring time accurately. Another important factor affecting the pendulum's time period is gravity. The pendulum relies on gravitational force to oscillate, so any change in gravitational acceleration will alter its motion. On Earth, where gravity is relatively constant, this effect is negligible. However, if a pendulum were taken to the Moon, where gravity is weaker, its time period would increase, causing it to swing more slowly. Surprisingly, the mass of the bob does not influence the time period of the pendulum. Whether the bob is heavy or light, the time period remains unchanged, as long as air resistance is minimal. This principle is based on the independence of mass in gravitational acceleration, an idea first explored by Galileo. One factor that does have a minor effect is the amplitude of oscillation. If the displacement of the pendulum is small, it follows simple harmonic motion, meaning the time period remains nearly constant. However, at larger angles, the motion becomes more complex, slightly increasing the time period. In practical applications, pendulums are usually operated within small amplitudes to maintain accuracy. Air resistance and friction also play a role in real-world pendulums. As the pendulum swings, it experiences resistance from the surrounding air and friction at the pivot point, gradually reducing its energy and slowing it down. Over time, these forces cause the pendulum to stop unless additional energy is supplied, such as in a mechanical clock, where an external mechanism compensates for energy loss. The simple pendulum has numerous applications in daily life and scientific study. It is widely used in timekeeping, as seen in grandfather clocks and certain mechanical watches. The predictable nature of pendulum motion has been crucial in early timekeeping devices before the advent of modern clocks. Pendulums are also used in seismometers to detect ground movements during earthquakes, and in physics experiments to study gravitational acceleration and oscillatory motion. One of the most significant aspects of a simple pendulum is that its motion is nearly independent of the mass of the bob. Unlike free-falling objects, where mass plays a crucial role, the time period of a pendulum is not affected by how heavy the bob is. Instead, it depends primarily on the length of the string and the acceleration due to gravity. The length of the pendulum is a major determining factor for its time period. A longer pendulum takes more time to complete one oscillation compared to a shorter one. This is because the pendulum has to travel a greater arc length while maintaining the same acceleration due to gravity. As the length of the string increases, the time period increases, making the motion slower. Conversely, if the length is shortened, the pendulum swings faster, reducing the time period. The study of pendulums has numerous applications in science and daily life. One of the most well-known applications is in the construction of clocks. Traditional pendulum clocks rely on the periodic motion of a pendulum to maintain accurate timekeeping. Since the time period of a pendulum is predictable, it serves as a reliable mechanism for measuring time in these devices. Pendulums are also used in seismology to detect and measure earthquakes. A large pendulum, suspended in a controlled environment, remains steady while the ground moves during an earthquake. This principle helps scientists record seismic activity and understand the intensity of ground movements. Another application of pendulums is in amusement park rides, where giant pendulum-like structures are used in thrilling rides. These rides rely on the predictable motion of pendulums to create smooth and controlled oscillatory motion for entertainment purposes. Another crucial factor influencing the time period is the acceleration due to gravity. Since the pendulum relies on gravitational force for its oscillation, any variation in gravitational acceleration will impact the time period. On Earth, the value of gravitational acceleration is approximately constant at sea level, but it changes slightly with altitude and location. For instance, at higher altitudes or on celestial bodies like the Moon, where gravity is weaker, the pendulum will take a longer time to complete an oscillation. The amplitude of oscillation, which refers to the maximum displacement of the bob from its equilibrium position, does not significantly affect the time period as long as the oscillations remain small. For small angles of displacement, the motion closely follows simple harmonic motion, where the time period remains nearly constant. However, if the amplitude is large, the motion deviates from ideal conditions, and the time period slightly increases due to the nonlinearity of the restoring force. Beyond practical applications, the study of pendulums extends to engineering and astronomy. Large pendulums, like the Foucault pendulum, demonstrate the rotation of the Earth, providing visible proof of planetary motion. In engineering, pendulum principles help in designing shock absorbers, amusement park rides, and even architectural structures that need stability against oscillations caused by wind or earthquakes. Understanding the factors affecting a pendulum's time period helps in refining measurements, improving designs, and appreciating the interplay of forces in harmonic motion. Whether in scientific research, engineering applications, or everyday timekeeping, the simple pendulum remains an essential concept in physics, demonstrating the elegance of periodic motion and the fundamental laws governing nature. Thank you. This is AskPrep, your guide to mastering NEET preparation. Let's decode complex topics and simplify your journey to success.